So Unit 4, Lesson 1. Going through system of linear inequalities and quadratic systems. So we're talking about straight lines and parabolas where they cross. Okay, you've solved system of equations in the past. You've done system of equations where they were just two lines. Now we're talking about systems with, you have the linear and quadratic, so you're looking at the parabola and the straight line. So the intersection points is what we're trying to get at. So when you get to calculus, you're going to end up finding the area of the shaded region someday. Okay, but for now, we're just going to focus on getting these intersection points, because that's kind of the first step in doing that. Is you got to identify the intersection points so you can set your limits on the area of the curve that you're finding. Okay. So on your calculator, we're going to go ahead and use the intersect feature to figure out these intersecting points. I'll let you do that. So in y1, go ahead and put x squared there, and your y2, put x plus 6. You should get something similar to this picture here. Make your y min on your window like -2, something small, so you get a nice good picture of the graph. Okay, when you use the intersect feature, when you get done with that, you're going to get this one, and they're going to come out as 2, -2, 4, and 3, 9. Okay, and what we're going to do now is we're going to show how you get that algebraically. So algebraically, you have y equals x plus 6, y equals x squared. So we want to identify that y equals and y equals these same things, x plus 6 and x squared. Since they both equal y, we can set them equal to each other using like a substitution type method. So x squared equals x plus 6. So what we're going to do now is we're going to go ahead and minus the x, minus the 6. So we have x squared minus x minus 6 equals 0. Use our factoring skills from earlier in this course, and we get x minus 3, x plus 2. The 0 property gives me that my answer for x is 3. My answer for 2 is -2. And it's no coincidence that that is my x's here, -2 and 3. Okay, we already know it's going to be 4 and 9, but to finish these problems off, you just take -2, and we just got to plug it in to either x here. So -2 plus 6 is 4. -2 squared is 4. We'll check it down here in a second. You'll see a little bit better. This one, put the 3 in. 3 plus 6 is 9. 3 squared is 9. And that would be your answers. So same ones we got using our calculator. Okay, really quickly, let's go ahead and verify. Okay, to verify, what we're going to do is we're going to use our point 3,9 and our point -2,4, and we're going to plug them into each of the two equations and make sure they're true. So my first test, I'm going to do this one right here for my first test. I'm going to go 9, because 9 is y, 3 is x, equals 3 squared. 9 equals 9, that's verified. Same thing over here, 9 equals 3 plus 6, 9 equals 9, that one's verified. Over here, 4 equals -2 squared, 4 equals 4, verified. And last one, 4 equals -2 plus 6, 4 equals 4, it's verified. Okay, and then so the way you can write these answers is you can write them as like x equals y equals separately, so 3, 9, -2, 4, or points 3, 9, -2, 4. Either one works. Okay, we just have an investigation and then some definitions, and that'd be it for this lesson. Okay, for this part, kind of with my window here, I kind of went out of room, so I need to, I'm going to go ahead and just do the work here, and then I'll graph it last. Okay, so what it wants me to do first is it wants me to algebraically determine the points, the intersection between x squared minus x minus 12 and y equals 3x. So from these two equations. So again, they both what y equals, so we set them equal to each other. Just like that. I'm going to minus the 3x, x squared minus 4x minus 12 equals 0. We want to factor. That gets me x minus 6, x plus 2 equals 0. So my zeros are 6, negative 2. To figure out my y's, we just plug it back in to either one. So if I put a 6 in for 3 times 6 is 18. If you plug it into this one, you'll also get 18. The negative 2, 3 times negative 2 is negative 6. So my points of intersection is 6, 18, and negative 2, negative 6. So I'm going to plot those now on the graph. So 6, let me move this up here a little bit so I have some room. So again, we got 6, 18, negative 2, negative 6. Okay, so if I go 6, 18, here's 6 right here. I'm going to move up. There's 18. Another point, negative 2, negative 6, 2 down, down to 6. There's my other point. That is where the line is going to cross the parabola at 2 points. If you want to make a little straighter line, you can just kind of do your slope. You know your slope's 3. So up 3 over 1, up 3 over 1. I went for the middle because there's no y-intercept. Okay. And then just draw a rough line through it. That would be the example of y equals 3x. Okay, I'm going to stay with this picture right here, and then I'm going to go ahead and do part B here, where now it wants 3x minus 16. Okay, so what's going to happen now is the same exact thing. We're going to go x squared minus x minus 12 equals 3x minus 16. Okay, I'm going to go ahead and add 16 minus the 3x, minus 3x, add 16. X squared minus 4x plus 4 equals 0. Now we'll try to factor that. You're going to get an x minus 2 and an x minus 2. Okay, which means I only have 1 0, and my one answer is just 2. Okay, so a lot like with our discriminant. If you remember with discriminant, we'd have 2 solutions, 1 solution, and 0. We're getting that same concept here, and we're actually going to use a discriminant to help us here in a little bit. So x equals 2. We need to figure out what the y would be. So with the y, we can just plug it in to either one. Let's plug into the easy one. Let's go right here. 3 times 2 is 6. 6 minus 16 is negative 10. If you plug into this one, you get the same thing. Okay, so 2, negative 10. Right here. Okay, so what this means is this picture, it's going to be harder for me to show you on to the right here, but we have a graph that it's just going to hit 1 point. That's called tangent. Okay, it's called tangent to the graph. So we're going to come through just like this and just hit it 1 spot only. Okay, and as I talked about, so the only thing we haven't talked about yet, we haven't talked about no solutions, and that's what we're going to do next. Go ahead and flip your workbook to the next page on part C. I'm going to stay here for the sake of the graph, and we're going to talk about the 3x minus 24. So I have same thing, same stuff, x squared minus x minus 12 equals 3x minus 24 this time. So I move my stuff over again. I'm going to get x squared minus 4x plus 12 equals 0. This is not factorable. Okay, when it's not factorable, we want to go back to thinking about quadratic formula. So that's a negative b plus or minus square root b squared minus 4ac all over 2a. And remember, this piece here is the discriminant piece. This tells us a lot about information in terms of how many answers to expect. So when I go and plug this in, you're going to see I'm going to get 4 plus or minus 16 minus 4 times 1 times 12 all over 2 times 1, which is just 2, which then is going to give me 4 plus or minus square root negative 32 all over 2. Now we should understand that this right here is a problem. Negative in the radical, we can't do that. So this is a case where there's no solution. Well, what does no solution look like? Well, if you graph it, it's going to completely miss the parabola and not intersect it at all. Okay, so it would be something, a little bit shorter hand version. It'd be like this. It wouldn't cross at all. Okay, and so that's it for that one. Now we've got a couple definitions, and then we'll be done. Okay, so completing the following statements. So we have, if a graph of a linear equation, if the graph is intersect at 2 points, then we have 2 solutions. It's that simple. If they're at 1 point, we have 1 solution. And if it does not intersect, like the last one we just did, then we have 0 solutions. Okay, and then down here, in the process of solving linear equation of systems. Now, when you're solving, what this means, the resulting quadratic equation is after we moved everything over and was equal to 0. So that was, if you think about it, that was the x squared minus x minus 12 equals 3x. When I subtract the 3x over, this is what they mean by the resulting. That right there is the resulting quadratic equation. Okay? So what it says on the first one is if it has 2 distinct roots, so go back to your discriminant rules. If you have 2 distinct roots, then you would have a positive discriminant with 2 solutions. Okay, if it was 2 equal roots, like the one we had earlier, just 2, then it's you'd be 0 for your discriminant, 1 solution. If it has no real roots, that'd be a negative discriminant, which would be 0 solutions. Okay, and that is everything for Unit 4, Lesson 1.